Okay, so this is the last video on trig substitution for the basics, but I only wanted to put in 3 questions because this one's not as crazy as the last one I've done. Well, I mean, I'm going to be honest with you, this one is actually a little bit easier compared to the last one. I think the only reason why I actually made this last is because of this specific question. I know it looks pretty easy, but then I realize it is actually easy. I think it's just the fact that you need to know so many identities that kind of threw me off. Because obviously, when you're working with just trigonometric functions, you're going to be having to know all your identities, and that's probably the biggest issue with all of these questions. Otherwise, it's chill. It's nothing wrong with it. So I'm actually going to be introducing what this trigonometric substitution method is. It's it's different to the last one, definitely, because now we are working with substitutions when we actually have trigonometric functions and not like rational functions with 2 terms in the denominator, which are perfect squares. Okay, so obviously this is according to the timestamps of the video. So whichever exercise you want to do the most, or if you want to do all of them, you can use the timestamps of the video. Let's get into the introduction. Okay, so I realized it would probably be a little bit easier to just start with the first example and then show you. And then you'll see there's going to be a repetition of this method. So I think I might actually make a video explaining when to use different methods. Like, when do you know when to use like this substitution method or use substitution? Which one is easier? So I might do that in the future, but not now at the moment. Maybe somewhere next year. But for now, we're focusing on answering these questions because you want your marks. You want to finish your mathematics degree. You want to move on to your future and all of that stuff. Start your own business most probably. So yeah, let's just get through this together by starting with the following, right? So let's look at the integral that we have. We have the integral where the lower limit is 0 and the upper limit is pi over 3, right? Okay, so it's a definite integral. And over here, we have cosine to the power of 4 theta, and we have sine multiplied by sine theta with respect to theta. Now, this trigonometric substitution is completely different to the other one that we've done. So what we are actually going to do is we're going to try and find or take the derivative of some other trigonometric function such that we get, that exists in this integral or integrand, such that we get sine theta d theta. Now I'm going to show you how we are going to do that, right? Well, according to our knowledge of derivatives, what derivative can we take to get sine theta? Now, the reason why we're doing this is because we want to replace d theta. This is a substitution where we want to assign a new variable. Okay, so this is what we are going to be doing. Now, we know that the derivative of cosine, doesn't matter the power, is going to be sine. It's going to give you negative sine though. Okay, so we are going to go back to our old friend called u substitution, right? We're going to assign a variable u, or you could actually do x. But I'm going to be honest with you, I'm actually going to deal with x rather. Because remember, when we were dealing with the substitutions, we were always like making like, let's say, theta the subject of the formula, x the subject of the formula, and all of that stuff. But actually, I'm lying. I'm going to be doing u. Because once again, this is basically either you do the t substitution or u substitution. It's the same thing, it's just a different variable. So we're going to do u. Okay, we're going to let u equal to cosine of theta. And you're going to see why I'm doing this, right? So we have cosine theta over here, right? Cosine to the power of 4 theta. And then we have sine theta d theta, multiplying by d theta. So that means we need to try and replace something like this, right? To get only one trigonometric variable. And that is exactly why we do this method. We only want one variable, or we only need one trig function. So note that if we take the derivative of cosine of theta, du by d theta, we're going to have an answer of negative sine of theta. And if we make du the subject of the formula, we're going to get negative sine theta with respect to theta. Okay. Hey, and look at that. If we do divide both sides by -1, we will get an answer over here of negative du is equal to positive sine theta d theta. Because we're taking the negative over to the other side, if you also want to think about it that way. So now what do you notice? sine theta d theta is equal to negative du. And sine theta d theta is represented right here. And that is exactly why we're going to be using the substitution. Meaning that we can just replace this whole thing with negative du. And because we have u is equal to cosine of theta, we can replace cosine of theta with u. Now let me just break this up quickly into the following. Before we continue, we know that this is going to be pi over 3. And then this is 0. And then what we can do is this can be written as cosine theta raised to the power of 4 multiplied by sine theta d theta. Okay. And now you can note, if it just makes it a little bit easier for you to notice, this thing is exactly the same as u. So we can replace u over there. Because the previous videos I didn't really explain that, but now I am going to explain it. Okay. But now remember that it's also a definite integral, meaning that we also have to deal with the upper and lower limits. So this is what we need to do. What I'm going to quickly do is actually just move this a little bit to the side so we have more space to do our integration. Okay. Now what we can do over here is the following. We know that our upper limit is pi over 3 and lower limit is 0. And remember, we need to find the upper limit of the u and the lower limit of the u, because that's our new assigned variable. Meaning that we already have our equation with u as the subject of the formula. So we need to plug in our theta limits, because we know that theta is equal to these values over there in those limits. Okay, so this is going to be equal to cosine, which is the upper one. Upper limit is pi over 3. And then the lower limit is going to be 0. We know that cosine of 0 is 1. And pi over 3, or cosine of pi over 3, is just going to be equal to a half. Okay. According to our special triangles. But I do remember this by now. So yeah, I do it a lot. That's why. Anyway, so now we can do our substitutions, right? So because we have negative du, and we know by this point that if ever we have any constant, in this case it's negative 1, by the du, we can automatically take it outside of the integral. Meaning this will just be negative integral. Or you could have said negative 1 integral, but once again it's not really necessary to say negative 1. But let's just do that for now. It's negative 1. Why? Because this was negative 1 du. Okay. And now over here, we need to replace cosine theta with u, which is our new assigned variable. So it'll be u to the power of 4, because of this exponent here. Multiplied by, or with respect to, u. Because, can you see that we are just replacing this entire thing with negative 1 du. But we already took the negative 1, so therefore, we're going to have du. Look how easy this looks now. This is way easier now. So we can actually just integrate right now. Also, before we integrate, whoa, definitely integral. We have a half and 0 as our upper and lower limits respectively. Now we can do this, right? We're gonna have negative. Let me just, okay. I don't know. I don't like writing the 1 actually. I'm gonna be honest with you. I'm sorry for all those people that like to write 1, but unfortunately, I am lazy. So let's not write the 1 there. You can write the 1 if you want to, if you're practicing. Now we need to integrate over here. What I normally do, it's going to, or let's just do it the way we normally do it. We know the coefficient is 1, so it's just going to be u to the power of 4 minus 1, 4 plus 1, because it's integration, which is equal to 5, divided by 4 plus 1, which is also 5. And then we have outside half and 0. Okay. Because now it's a definite integral, we don't have to say plus c, because they're going to cancel out anyway. Okay. Then we're going to have the negative still standing outside like that. And then what we have is also, we can substitute. So we're going to do this first. Let's just make it a little bit easier to read. We can also write this as a fifth multiplied by u to the power of 5. And then we have our upper and lower limits like this, 1 over 2 and 0. Okay, there we go. Now we can just evaluate. So what we are going to be doing is we are going to take we're going to be using the form f of b minus f of a. Okay, where this is equal to our b and this is equal to our a. So now what we're going to be doing is we're going to have negative, and I'm going to keep the square bracket for now, but we're going to have the first one, which is going to be with the upper limit. This is going to be a fifth multiplied by a half, all raised to the power of 5, and this is going to be minus with the lower limit now this time. It's going to be a fifth multiplied by 0 raised to the power of 5, and then this is going to be yeah, that's about it. And I just realized something, by the way. Here's the mistake that I've made. This is supposed to be 1, right? The lower limit is actually supposed to be 1. I know I paused the video, I was thinking, this doesn't look right, because I've done this already, right? And I was like, whoa, what mistake did I make? Well, apparently the mistake that I've made is I did the incorrect substitution. Ooh, this was supposed to be 1. Because remember, that's what we found the limits to be. I just kept it at 0, because there's so many damn examples where we have 0 as the lower limit. So I blame the examples that I've done in the past. No, I'm joking. I'm not going to start blaming things now. Okay. So this is 1, by the way. I do apologize for making the mistake. It's all on me. So yeah, there we go. Now we can just continue with this. And if you plug all of this into your calculator, and I do apologize now. I know I'm not the cool guy anymore because I don't normally use calculators. But I do want to make the length of these videos a little bit shorter, since obviously you're learning how to do this stuff and not learning how to do it without the calculator. You can actually apply all of your basics to actually find the answer. Then you'll get an answer of 31 divided by 160. And that is what you should get for the answer over here. So that was the first one. And if you still didn't get a glimpse of what we are doing in this video, watch the next one. You'll also most probably understand, or even for the last one. Okay, so let's move on here. Alrighty, number 2. Now what we are going to be doing is the same method. Well, I mean, that's the whole video, right? Isn't it? So over here, right? The first thing I'm pretty sure you should be used to by now is that we need to just maybe take this over, right? So that we get like something multiplied by another thing. Especially with this method, that's normally how it would work. Because what we do note over here is the following. And I want to quickly show you what I'm getting at right now. So note that when we write this integral again, so we're going to have the integral where pi over 2 is the upper limit and pi over 6 is the lower limit, right? So from here, what we can do, we can also write this as 1 divided by sine cube of theta. And what do we notice? We can also write cosine theta with respect to theta over here, right? And it's kind of the same as the last example. Do you note that? We have cosine theta multiplied by d theta, meaning that maybe we need to take the derivative of sine so that we can get something like this. Let's try that quickly and see if it works. So we're going to let u be equal to sine of theta. And the reason why I let sine theta be equal to u is because it has an exponent. And obviously it'll be weird if we have to do something else, right? We don't want to make it more complicated. We want to make things easier for ourselves. We are lazy people, and let's admit that, okay? By the way, I'm just speaking from my perspective. I don't think everyone's lazy. So yeah, but what I'm saying over here is it makes life so much easier for yourself. So which means that's why we make u equal to sine theta, so that if we substitute u into the equation, this will be u cubed, right? And there's no issue. So therefore, because we have u is equal to sine theta, we can take the derivative on both sides, du by d theta, and this will be positive cosine of theta. And we let du be the subject of the formula. It will be cosine theta with respect to theta, right? And I'm just gonna once again move this to the side here, so that we don't have it in the way of anything else. Okay, now that's what we note over here. Does this satisfy what we have over here? Absolutely. We have cosine theta multiplied by d theta, cosine theta multiplied by d theta, which is equal to du, which is perfect in our case. Now we can substitute. But once again, because we're working with a definite integral, we need to find a new upper and lower limit to satisfy our new variable substitution. Okay, so the upper limit of the u and the lower limit of the u, let's just see. We can see we have something in terms, with u as the subject of the formula, so we can just directly substitute into theta. Sine of, which is the upper limit over here, pi over 2, and then we will have on the lower one, sine of pi over 6. Now, if you want to put it in a calculator, or if you want to use the, the special triangles, this one you can use a special triangle, but we know that sine pi over 2 is just equal to 1, right? And sine pi over 6 is just going to be equal to a half, right? Because that's basically just sine of 30 degrees, if you wanted to use degrees. But hey, sis, why am I talking about degrees? We're talking about radians here. We're doing A-level mathematics now. Degrees are meaningless now, okay? unless you're talking about temperature. So yeah. Anyway, so what we have over here is now we can substitute everything in now. Let me not make the same mistake that I've made the last one where I substituted the wrong values in. And what we note over here is that there is no coefficient of the du, so which means we don't need to put anything at the beginning of the integral, meaning that we can just say it's the integral of the upper limit, which is 1, and the lower limit, which is 1 over 2. Just make sure that that's correct. Okay, and what do we note here? We can substitute u into sine cubed theta, meaning that we'll have 1 divided by u cubed. And then because we know what cosine theta d theta is, it's equal to du, we can just substitute that directly. And now we have an integral that looks like this. And that is perfect. That's exactly what we want. Okay. And now from here, what we can do is we can actually integrate straight away. But before we do that, let's just do this first. We can write this as u to the power of negative 3, which will actually make our integration easier, which we actually should just do in general anyway. We should have just known that we had to do that. Now we can integrate, okay? So that's what it's going. This is what it's going to look like. It's going to look like this. It's going to be u raised to the power of negative 3 plus 1, which is equal to negative 2, which means the denominator also has to be negative 2, okay? And then this over here is going to be 1. This is going to be a half. And the plus here doesn't need to be written because it's a definite integral. Okay. And now what we can also do is the following. We need to make this easy to simplify. Just in case you don't want to do it in the calculator, let's just try and do it so that you don't have to put it in the calculator. Okay. So what we're going to do is the following. We are going to write this as negative 1 over 2 multiplied by u to the power of negative 2, which we can actually write as 1 over u squared. Okay, then we have 1 and a half. So we can just substitute in our stuff from there. Okay, and then from your answer on the calculator, if you did use or let's rather just substitute first, right? So we can actually write it like this: negative, let's see. Yeah, negative a half multiplied by 1 over 1 all square. This is going to be minus, and then we're going to have negative a half, which is basically the same thing now, but we have a different value, multiplied by 1 over, and it's going to be a half all squared, like that. And then you can just plug it into your calculator if you want to, or you can simplify further. But you should get an answer of 3 over 2. That should be your answer for this integral. So let's move on to the last one. But the last one is going to require us to know a lot of identities. Trust me, yeah, it was, when I got to the answer, I was actually shocked. So yeah, let's just go through this now. Okay, the final one. For this one, it's going to be a little bit more tricky because, okay, look here, right? We only have one trigonometric function. And the reason why we can't use u substitution yet is because we just need to write it so that we need to actually change this expression here, or this integrand, such that we have some expression that is integratable, if that's even a word. So over here, what I think, in my opinion, this is not really a trig substitution, but it kind of has that same, well, I mean, I'd say it does, because once again, this textbook has it under the trig substitution, so I will include it for this one, and I'll show you exactly how we go about getting the answer. If you want to try this yourself, go for it, and then if you do get it right before I do finish, then good for you. So yeah, let's just get into this one. Now, we can't do a substitution now. We have a little factor that's kind of affecting everything, so we need to kind of simplify it, or we need to change it so it is integratable. Okay. So how do we do that? Let's do this quickly. Okay. So we're gonna write it like this. It's gonna be the integral of. We can actually rewrite it like this. It can also be written as sine squared theta raised to the power of 2. Because we're basically breaking this for sine 4 theta, or sine to the power of 4 theta, like this over here, with respect to theta. Okay, and now what we can see over here is we have sine square theta, right? Which we can actually break up into something else. But before I do that, I actually want to write this twice. So the reason why I wrote it in this bracket is to show you that we can actually change it like this. We can write it as the integral of sine square theta multiplied by sine square theta, right? Because it's a square, it's multiplying itself twice with respect to theta. And that is why I wrote that down like that, using our exponent laws initially, then breaking it up. So now from this point, like I say with trig substitution, let's just keep it this like this over here, right? But we're going to quickly change this one so you can get a different trig function. So we're going to have the integral of, this is going to be sine square theta, which can also be written as 1 minus cosine square theta according to our identities. And this is going to be multiplied by sine square theta with respect to theta. Now from here, what else can we do? Okay, let me write this square properly because it looks like a question mark without the dot. So what you notice over here is that we can actually take this into these two terms over here of this bracket, right? The sine square theta can go into the bracket. So therefore we can actually write it as, this is equal to the integral. I'm going to keep this as, oh no, you know what, it's fine. Actually, now I'll just go along over here, right? So this is going to give us sine square theta because it's sine square theta multiplied by 1. And then it's going to be minus sine square theta multiplied by cos square theta, which is going to look like this. It's going to be a sine square theta multiplied by cosine square theta. Okay, d theta. And now what do we notice over here? We are kind of getting close to something that looks kind of like a double angle. Whoa, hold on there. Kind of looks like a double angle, doesn't it? But we have these squares over here, and we don't have a 2. So this is actually something we can do, right? So over here, you can say this is the integral, and we are going to say sine square theta. Let's just focus on this one for now. We're going to distribute the exponents such that we have sine theta multiplied by cosine theta raised to the power of 2, because that's our exponent law. So we can distribute the exponents with respect to theta, like that. And now I want you to focus on something quickly, right? Let's look at our identities like this, okay? So what do we know? We know that sine 2 theta is equal to 2 multiplied by sine theta multiplied by cosine theta, right? So that is one of our double angles for sine theta, or it's our only double angle for sine theta. But if we want to make this, or if we want to make this equation look something like this, note that that is right over there. But this 2 is in the way. So let's divide both sides by 2, and then therefore we'll get an answer of, I'm just going to write it on this side, sine theta cosine theta is equal to sine 2 theta divided by 2. And that is what we have. So we can basically just plug in this into that over there. Okay. We're kind of getting rid of the exponents basically, like so. We're making it easier to substitute. That's what I meant to say, sorry. So we're going to have sine square theta minus, and we're going to have the bracket over there. It's going to be sine 2 theta divided by 2 raised to the power of 2 with respect to theta. Okay, so that's what we have so far. Okay, so obviously now we can actually take the square in, like so. So this is what we're going to be doing. But before I take the square in, we need to look at one more identity quickly. We might have to look at a couple actually. Never mind. I'm lying. I'm not going to do more than, I'm not going to say that there's not that many identities. Trust me, there's a lot of identities that we need to know. Okay. So by using the reduction formula identity, right? And it goes as follows, right? We have the following. We know that sine square theta is actually just going to be equal to 1 minus cosine 2 theta divided by 2. Okay, so that's what we can substitute in for. So what are we going to do here? We're going to say over here that the integral of, we're going to replace sine square theta with exactly what we've just shown over here. This is going to be 1 minus cosine 2 theta divided by 2 minus, and then we, like I said, we're going to distribute this square back in to what we have. So we're going to have sine square 2 theta divided by 4. Okay, with respect to theta. And now from here, note that we have the following. And this is actually a barely recognized identity that we have. Now, what I want to show you is the following. This square over here, so let me just do this. This square is ruining everything, right? Because it's there and it's going to make us our answer a little bit more difficult to integrate. So what I want you to look at is the following, right? If you remember, it happened literally just now. We had sine squared theta is equal to 1 minus cosine theta, 2 theta minus, and then we had 2, divided by 2, okay? Now, one rule that we need to remember over here, or that we need to know, is that if we double the angle on the one side, we have to double the angle on the other side as well, right? Or it happens even if you're halving the angle. If you half the angle on one side, you have to half the angle on the other side. So what do I mean by that? Note that we only have one ratio over here, trigonometric ratio, and we have one trigonometric ratio over here. So if we double this one here, so if we say sine square of 2 theta, then this means that we also have to double the cosine one. Therefore, this will be cosine 4 theta, because it's double of 2, basically, which is 4. And there we go. Note that we only doubled the angles and we didn't double anything else. That is something we need to know. And that was the part where I was stuck on. I was wondering. And then I looked at the rules and I was like, whoa, you can do this? Because trust me, I'm also kind of new to all of this stuff. Not really, but like I must get used to it. That's what I'm basically saying. Okay. So hey, guess what? In our new equation, we don't have any power. And over here, this is exactly the same as what we have determined here. Can you see what we've done? So that's what we're going to be replacing it with. So note that we can actually write it like this. It's going to be the integral of 1 minus cosine 2 theta divided by 2 minus, and then we can also write this as sine square 2 theta multiplied by 1 divided by 4. Okay. And then over here, this is with respect to theta. And then over here, what we can do is we can just rewrite it like this. We need to substitute now. Cosine 2 theta divided by 2 minus, and what is sine squared 2 theta? It's equal to 1 minus cosine 4 theta over 2. So it's basically, if we multiply them together, we'll get 1 minus cosine 4 theta divided by, and then we're going to have the two denominators multiply each other. It's just going to be 2 multiplied by 4, because remember the 2 comes from this over here, this denominator here, and the 4 comes from this denominator here. So we have to multiply them together, which will give us 8 over here in the denominator with respect to theta. So our next step now is to put it into one fraction. Okay, so let's make it into one fraction so we can do the following. We're going to say this is equal to integral of, because the lowest common denominator is 8, we can say, so LCD is 8. We need to just multiply this by 4 and also the top by 4, right? And then we just multiply this by 1 because, once again, this is 8, so we don't really need to change anything. Okay, because it's our LCD rules. We should remember this from primary school. Okay, so then this will give us an answer over here of 4 minus, and it will be, so 4 minus 4 cosine of 2 theta. Reason why is I'm just multiplying the 4 into the stuff already. Basically, it kind of looks something like this actually, right? So it looks more like this actually, where we are multiplying the 4 into both of these terms here. Okay, and then we're going to have divided by 8 minus, and then we're going to have 1 minus cosine 4 theta divided by 8, because we didn't really change anything there. And now we notice that the denominators are the same, so we can now write it as a singular fraction. This is the integral of, and we're going to have 4 minus 4 cosine 2 theta divided by 1, minus, and then we're just going to put a bracket over here, like so, 1 minus cosine 4 theta, okay? Because remember, now we have to put this bracket here because this minus is affecting the entire fraction. and this is all divided by 8, which we can also write as 1 over 8. So I'm going to show you what I mean basically. This is also just going to give us 1 divided by 8, right? Meaning that we can take 1 over 8 outside of the integral. So we can basically write it like this. It's going to be 1 over 8 multiplied by the integral of, now we basically got rid of the fraction. Can you see now? This is going to be 4 minus 4 cosine 2 theta, and we're just going to take the negative into these two terms over here. Therefore, it's going to be minus 1 plus cosine 4 theta with respect to theta. Okay. And now we can just take the like terms. This is equal to 1 over 8 integral, and then we're going to have 4 minus 1, which is equal to 3. So we're going to have 3, and then we have, so since we dealt with that, we need to do all the other like terms over here, but we don't really have other like terms, do we? So therefore, what we can do, or what we are left with, is we are left with minus 4 cosine 2 theta, and then this is minus cosine 4 theta with respect to theta. Okay, so that's what we have so far. Don't worry, we're almost by the substitution. This was an intense one when I first did it, but let's just move on here, right? Now what we need to do is distribute this integral into it, basically. So the 1 over 8 multiplied by the integral, we need to distribute to this term here, that term over there, and that term over there, because it all falls under that integral there with respect to u. So that is what we are going to be doing. So we can rewrite it like this. It's 1 over 8 integral of 3 with respect to theta. Sorry, did I say u? I meant theta, sorry. Minus 1 over 8 integral of, and this is actually going to be, because this is a negative, I do recommend maybe taking the negative immediately outside, which gives it a positive, like this. It's going to be 4 cosine of 2 theta. Then I might as well just download the 4. But it's fine. You know what? Let me just write it like this first. It's a negative 4. Okay. So then we still have a minus. We're going to take it all out soon. And then this is going to be minus integral of, minus 1 over 8 integral of cosine of 4 theta with respect to theta. I forgot to say it over there. So let me just rewrite it again. This is a very long question, so I apologize. This is going to be minus 1 over 8 integral. And we're going to have cosine 4 theta with respect to theta. Okay, now we have that. Now we have 3 integrals to solve. Okay, one of them is the easiest one, which is basically this one. But let's just quickly simplify the stuff, right? If I want to simplify, let's just do this quickly. We can rewrite it like this. We can see that this, okay, so let's leave this constant the same over here, because remember we do need to take this theta into the 3. So what I do recommend, maybe just keep it the same if you can. This is going to be 1 over 8. Or you can take it out, but I mean, I wouldn't. So we're going to have 3 d theta, because we don't really need to simplify it further. But what we do see over here is we have a constant, which is negative 4, which we can actually take out. Therefore, this will give us, this will actually tell us that this is negative 1 over 4, negative 1 over 8 multiplied by negative 4, which will actually just give us positive 4 over 8, which is equal to half. Positive a half, meaning that we'll just write it as plus 1 over 2 integral of cosine 2 theta with respect to theta. And now over here, we're going to say this is minus, so there's no other constant, so we can just say that's minus an 8th integral of cosine 4 theta with respect to theta. Okay, so here we go. I'm assuming you guys are all excited for this one. It's the part where we substitute. And now I'm going to write it here. So the first thing, what do we notice here? What can we substitute? Well, it's not a trigonometric substitution really, which I'm kind of disappointed in. But what do we see here? We have 2 theta, which makes things complicated for us. And we also have 4 theta, which makes something complicated for us. Meaning, we might not actually have to take 1 substitution. We're probably going to have to do 2 substitutions. And this is a great preparation for integration by parts, where you have to take 2 substitutions to make things easier for yourself. But this is not really exactly like integration by parts. This time we're actually taking 2 of the same, well, we're not taking any derivative and integral. We're actually going to let u equal to something and another variable, let's just say v, for example, be equal to. We're not taking dv for people who actually know how to do integration by parts. We are taking u and v. Okay. So what are we making u equal to? Let's first deal with u, not v yet. Okay. So u, let's just let that equal to 2 theta. Okay. So that we can find a way to replace it, right? And then what else do we have? Well, we have 4 theta. So let's let v equal to 4 theta over here. And then because we did the substitution, we're going to take the derivative on both sides. I'm immediately going to make du the subject of the formula. This will be 2 multiplied by dv. I mean, not dv, d theta. Okay? And then this will be dv is equal to 4 with respect to theta. Like that. Right? So that's what we have. If we just immediately make them the subject of the formula. And then therefore, because we want to replace d theta, because of the substitution, we actually need to do the following. We need to divide both sides by 2, and divide both sides by 4 over here. Right? This is actually a 4, this is a 2. And then therefore, we can actually write this as a half du is equal to d theta, meaning we can actually replace the d theta over there. And then over here, we can say that this is going to be a quarter multiplied by dv, which is equal to d theta. Okay, great. Now notice that we have 2 d thetas, right? Couldn't we just substitute both of them into this one over here? Absolutely not. Well, note how we actually assigned a certain variable du, meaning that this d theta can apply to this integral, right? Because we have done it for this 2 theta here, and then this integral should actually assign for this, this d theta, should assign for this integral here because we did assign it for 4 theta, which was right over here. So you must be careful of which one you substituted into, because whichever integral you did substitute for, you need to use the correct d theta for that, or dx, or whatever you assigned. So now we're going to substitute. Well, note how, first of all, the first integral here, we can actually directly integrate. But let me just write it again. Okay. So we have, this is going to be equal to 1 over 8 integral of 3 d theta. Okay. And then over here, we are going to have plus a half. Okay. So yeah, plus a half. And because we are assigning this one first, the half one, we're actually going to take the half out of the integral. So therefore, it's going to look like this. It's going to be a half multiplied by a half. And what is a half multiplied by a half? We will have it as 1 over 4 integral. Okay. And then we remember over here, we assigned our new variable. 2 theta is equal to u. Okay. So therefore, it is cosine of u. Okay. With respect to u. Like that. And now over here, what's our other one? We have minus 1 over 8 integral cosine 4 theta. We know that 4 theta is equal to v, and d theta is equal to 1 over 4 dv. So therefore, we can actually write like this. It's going to be minus 1 over 8 multiplied by, because we're taking this quarter out of the dv, 1 over 4. And this 1 over 4 multiplied by 1 over 8 can also be written as 1 over 32. Like this. Integral. And we're going to have cosine of v with respect to v. Okay, great. Now you can see, look at this. This is great. We can just integrate straight up now. Okay, integrate them all. And because it's not definitive, meaning that it doesn't have any upper or lower limits, we just say plus c at the end, right? So this is what we're going to be doing. We're going to have 1 over 8. We're going to take the first integral here, and we're going to have 3 theta. Right, because that's our integration law. We take whatever we have with respect to and multiply it by the constant, when it's just a constant, obviously. And then we have plus 1 over 4, and this is going to be multiplied by the derivative of cosine u. Now, looking back at this, right, I know that I made a mistake. Okay. If you saw it in the beginning, I do apologize. I know exactly what mistake I made. So this was the mistake I made. And it's not really an impactful one, but it does affect your answer. So let's just hope that you didn't actually exit the video by this point. This over here, do you note how this is negative 4? I shouldn't have done this because the negative only shows up once. So therefore, this is actually positive. Therefore, this answer would actually just be a negative. And then therefore, this one would be a negative. This one would be negative as well, because obviously there was not another negative sign, and that was the only impact that it actually had. So it wasn't a huge difference, but it is a difference to the answer that we would get. So yeah, just please be careful of your signs. And once again, I am in the midst of making a video, so obviously I'm under that pressure of trying to get you guys marks up over here. But if I keep making these mistakes, I'm really gonna have to find a way to sort these out. Okay, so over here, what we're going to notice, we need to take the derivative of cosine, right? We know the derivative of cosine is just positive sine of the angle plus c. But here it's going to be sine of u, like that. Okay, the plus c will come at the end. And now what we have over here is we're going to have minus, well, I mean, looking back at this, it should be a positive. I looked back at the answer, so check it. I'm also going to show you this. Okay, so let's look back here. Right here, here's the issue. Plus for cosine for theta. This should have stayed positive throughout. Do you note how I actually changed the sign over here? Now, like I say, if you do see these little mistakes, do let me know in the comments below. Just obviously, if I don't notice these mistakes, just do let me know. Once again, I am trying to grow as a mathematician here, and I do see a lot of mistakes here. And then here, this should also be a positive, then, in that case. And then therefore, this must also be a positive. And then this must also be a positive here. Okay. So that was also one little mistake that I've made. Now we need to integrate in for v over here. Okay, with respect to v. So we have 1 over 32, and I hope that's the last mistake that I've made. Otherwise, please let me know what other mistake I've made. So, because I remember when I was actually doing this, I didn't really make that same mistake. It's just under the video circumstances. But I will do better, don't worry. I am a little bit nervous, I'll admit that. But yeah, let's just continue here. This is sine of v. What is happening here, man? Sine of v. And over here, we have plus c at the end. Okay. There we go. Because we took the integral of cosine of v with respect to v. And now from here, we just need to substitute back. But what do we have initially? Initially, we had it with respect to theta. So therefore, we need to have theta in the final answer over here in the expression. Okay. So all the way here, we need to substitute. So this would just be written as 3 over 8 theta, okay? So that's basically, we already done with this term over here. But this term, we just need to substitute back. So we're going to have minus 1 over 4 sine of, what is u equal to? Well, u is equal to 2 theta. So that's what we're going to substitute for. So it'll be sine of 2 theta plus, this will be 1 over 32 multiplied by sine of v, which is equal to, it was equal to 4 theta plus c. And there's our final answer. Now, this video, it had a lot of mistakes, I know, and I do take accountability for those mistakes. It's my fault. Obviously, I don't want to redo the video because these videos, it's really long, and I do have other things that I really want to do. And I just want to take the time here to just tell you that it happens a lot. And if you don't want to listen to this, I do apologize. You can just leave. But things like this does happen a lot. I do make these silly mistakes, but mainly when I'm under pressure. When I'm all on my own, just doing math on my own, I don't really make these mistakes. But once again, I'm doing my best to get used to this. I'm still a little new to this content stuff, but I will improve as we go, and your support is definitely going to be valuable towards me, and the critical and the criticism as well that comes with it. I really need the criticism to improve as a mathematician and to improve this YouTube channel so that we can reach our milestones together. Okay, so if you do have any questions, leave it down below in the comment section. And that was the last question over here for the method 2 for the trigonometric substitution.